also is very serious about AI, and we want to walk the talk instead of just saying that I'll give data, I'll give company, I will set up some innovations, go to China, to other countries, and it's all very fragile. Animals obviously can't defend themselves, and all this is going on. So we have been able to support the development of a picture recognition based solution enabled with AI, which alerts the forest officials whenever any such image is seen, which is not of a regular animal which is found in that forest area or in that wildlife sanctuary. And it is running for the last few months, more than 1 year, I would imagine. And the initial results are very, very encouraging. We have created another AI-based solution along with Triple IT and Intel, which is called iGasting. Someone might have spoken about it earlier to you, which alerts drivers at the locations where accidents typically happen. So accident-prone zones, and the algorithm also takes in account the driver's own behavior of what kind of quality of driving is provided. So we have installed this solution in 2 national highways in RTC buses, and the data shows that there is a reduction by 40% in the accidents which typically used to happen in those roads. So many such examples are there. As I said, 25 plus examples are there, and we are always on the lookout for more and more use cases, so that instead of just teaching, we will also be walking that talk. One third example which I can share very briefly. Again, I feel very, very proud about that solution. This potentially is a global solution. Across the world, this can be adopted. This relates to remote voting. All of us know, and coincidentally, this is the election season. On the 13th of May, we will all be required to go and vote. Now, it's of course a very important part of democracy. It is our duty. We all have to go and vote, but many people find the whole experience of going out and voting to be a very cumbersome experience. And many times it is also very user unfriendly. You go somewhere, you stand in the queue, and at the end it is found that your name is not there or someone has voted in your place. So it also creates a big hassle. So we have been able to develop a solution which allows you to vote sitting in your home using your phone. And as you know, voting is a very contentious process in our country. People keep complaining, people keep challenging. Typically, after every election, electronic voting machines are blamed that they were faulty. I pressed this button, but all the votes went to someone else. But so even in this kind of an environment, we were able to successfully demonstrate in a live scenario. There is a town called Khammam, about 350 kilometers from here. In a municipal election, we were able to demonstrate with about 3,000 voters that without stepping out of your home, you can cast your vote completely successful, without even 1% of any doubt or any error, etc. And the AI played a very important role in creating that. So it's an image recognition solution, but how is your image evaluated? With lots of AI behind it. So as I said, many such solutions have been created. The other important responsibility which the government takes is to work towards ethical use of AI, have a proper governance system, have a system which is promoting responsible usage of AI. So we have created an institution in the government which is called Telangana Artificial Intelligence Mission, and it is headed by the India head of NVIDIA. NVIDIA, as you know, is today one of the champion companies when it comes to AI. So their India heads our team. And there are members of other private companies, members of Transform, members of academic institutions, as the government representative I am there. So this institution looks after all the governance issues, data sets, responsible AI, what will be the ethical usage, which use case will be taken, how will we allow a startup to develop their solution. So this is a very robust mechanism. Again, very few governments, very few states have done something of this kind, which we have done. We are also very keen that we play an important role in popularizing AI usage through frequent activities, events, meetups. There is a strong AI community here. The present event that we are all participating in, AI Days, is one such example where we have been able to bring together all the stakeholders. I'm happy to share with you that 2 months from now, in July, on 8th and 9th, one of the largest AI summits which have ever happened in our country is going to take place here in Hyderabad, the Global AI Summit. And again, the focus of that summit is, while we are still working on it, I can share this very briefly, that the focus of that summit will be to show use cases. I mean, we have spoken enough about theory, we are now speaking quite a lot about AI, we are speaking about responsible AI, ethics in AI, but where are the use cases? So we want to show that literally every field of life, AI has a use case, someone somewhere is using it and benefiting from it. So how do you get exposed to all these amazing use cases? How do you decide to use some of them yourself? Or how do you tweak it? Or when you hear about some use case in some field, does it give new ideas to you on how it can be used? So it's a very practical kind of focus event on the 8th and 9th, as I said. So I'll invite all of you also to register for it, participate in that. Registration will be opening possibly in the middle of April. So look forward to these kind of events that are happening again and again and again. So once again, I feel very happy that the 2 days conference here, AI Days, has been a resounding success. I particularly appreciate the initiative of developing the Telugu LLM, and of course, this is an opportunity which will help the next billion users of internet. Most of the next billion users of internet will be using it in their own language. They will not be knowing English. They will not be having any kind of advanced college degrees. They will be living in rural areas. So language should not become the barrier, and therefore the effort to effectively work on large-scale local language models is very noteworthy. We are also making similar efforts, and I'll be happy to kind of collaborate and synergize. We have got permission, so it has not yet been officially announced. We have got permission to access the database of a huge Telugu newspaper. This newspaper group has millions of articles, millions of publications, and the entire archive has been made available to us. So this again is a very good kind of resource for us to train our model and make it more and more accurate. Eventually, accuracy is what will push the needle. This voting solution that I spoke about, we have not been able to kind of scale it up or convince the election authorities or the election commission of India, because it is still not 100% accurate. So it is, I mean, the accuracy levels are very good, 87% or something like that. But till it becomes much more accurate, no one will really be able to give 100% confident kind of acceptance to it. So this is again something which we need to do collaboratively. We need to pool our resources. And as I said, I'll be very happy as the government will be very happy to support any such initiative which is going on. So once again, good wishes to all of you, and thank you very much for inviting.
One small announcement, my request, Kiran Chandra, founder Sweksha, Professor Pratap, President Sweksha, Chaitanya, co-founder, CTO, Ozotel, Nagendranath Garu, Senior Advisor, Salamander Advisory Services, the Honorable Vice Chancellor, Kata Narasimha Reddy Garu, so if you can also please join us on stage for 1 minute. Nag Malladi, Vice President, Tech Mahindra, Srinivas Mohan Garu, again, there is no introduction. You've all seen Bahubali, RRR, Turado. He's the person behind all of that stuff.
We're going to set up a center here called as the Center for People-Centric AI. The spirit with which the conference has begun, solving problems for the commons. Thank you, JHRU, saying that he will be supporting us all through. He has been always supportive of it. And I think this center is going to look at solving problems for the commons. And I think all the scientific community that has been sitting here has listed close to 200 problems or odd problems since all the speakers were going on yesterday. So I think we'll start solving some of them, and hopefully we'll be able to present in the conference that is going to be there. And in these 3 months, we have solved X number of problems.
We've already a few institutes, including IIIT, a few companies, they're also represented over here, signing up, universities and all. There are a few companies which have signed up to be founding members of this center as well. There's an open call. I know there are a lot of companies, startups, research institutes, including in the likes of CCMB and others who are a part of this. We're also proud to announce that the cyber cell, they were there yesterday, the institute was there. They wanted to partner in the center that we are setting up as well. So if you're interested, please do reach out. This center over the next 1 year, we will be working towards innovation AI for society. Hubs will also be there across the year. This is not just, this will be centered in Hyderabad. We are opening up hubs in Madras, Bombay, Chennai, Mumbai, Bangalore, other places as well. This is going to be a huge initiative where we are going to be working on use cases. If you're wondering why we have this, we have demonstrated farming and agriculture use cases yesterday. This will actually be, we will be releasing lots of use cases as we go forward. This is an open invite. If you're representing your company, industry, startup, whatever it is, if you're interested in building people-centric AI solutions, please do reach out to us. We're going to be actually launching the center in a month's time frame, and we look forward to collaborating with you. Jayesh Garu has also said they're happy to collaborate with us on all of these things, and we'll be more than happy to work with the government and other organizations which are working with the vision of people-centric AI and AI for society. Thank you. And then we have spoken about how AI is going to take over, right? We started to say something that we have built, executed with a vision towards AI. The AI vision was 2017 when we held the DevCon 2017. We've spoken about AI vision. 7 years later, why don't we, do a future perspective? Where do we think we'll be? I am quite sure we will be entering the era of quantum computing. So with that note, I think we should conclude the conference with Dr. Krishna Palam Garu, the founding CEO of AcceleQuant. He's going to be talking about the intersection of AI, ML, and quantum computing. Sir, I think you should please join us. And 7 years, 5 years down the line when we are here, that could be the current, that could be the present. Because 7 years ago we started talking about AI, ML taking over, and here we are today. Probably 5 years later we will be calling it AI quantum days or something like that. But nobody better than Dr. Krishna Palam Garu to talk about the intersection of AI, ML, and quantum computing. I know it's a very curious topic for all of us. Nothing better than you speaking to close this out. Thank you so much for obliging and joining us over here. This is on.
Yeah. Okay. So I made you one promise. I will let you go in 25 minutes. You don't ask me any questions. And that's at the end of long 2 days. But this topic actually would have been done better than like early in the morning, because it can be quite confusing, and I'll show you why. I'll start out by giving you a 5 to 10 minute overview of what quantum means. Then we'll talk about what it really is used for and potentially in the AI space as well. So I'm right now running that company, so I don't want to go into the company specific things too much. So the spirit of what I do is just an overview of what's happening in the field. You see those words on the left, I'll walk you through those. Those are terms used very freely, quite often without attribution of what it really means. So I'll start trying to give you a feel for the basic vocabulary of what quantum anything is. And then we'll move from there to trying to see how we can use it. So these are cartoons which are very, very approximate. So you can easily misinterpret them, but I deliberately watered them down so that you can understand what the real meaning is. So normally we all know that there are things called bits that you compute with. Quantum lives in the world of something called qubits. So a bit is simply a 0 or a 1. And typically when you build these ICs, integrated circuits, out of semiconductor material, there is a high voltage or a low voltage. And this voltage can be thought of as encoding a 0 or a 1. Qubits are done in a much more complicated and even somewhat bizarre way. So, and this is where things could get inaccurate. You actually manipulate and encode information not at the level of charge, which is about, 10,000 to 100,000 electrons, which is called bulk charge, but you can start manipulating individual electrons. So a single electron, when you start moving it around, it really doesn't want to move around the way you want it to. So the way you can think about this conceptually, there's a lot of mathematics and physics behind it, is that black dot, if you want to encode the information on it, depending on its energy level, you use a tiny laser tweezer and actually move the electron to where you want it to be. And this now lives in a super cooled bath, which is held at a very, very cold temperature, and hopefully it will live there for some time. And that encodes your information. So the mechanism through which, and there are lots of different ways of doing this. There's light-based quantum qubits. This is superconducting material-based qubits. But there are different ways of building them. But they're all manipulating extremely fine-grained phenomenon, because I'm sure all of you have seen, whether you like it or not, some point, the concept of quantum in the physics world. So quantization really is quite old. What it really builds on is, by virtue of doing what we just said, you can stack these qubits and they can encode states that are much more complex than bits. That's about the basic idea. And so if you think about classical bits, each bit is a 0 or a 1. Depending on the number of dots, you take that many times 2 as a total number of possible combinations. In a strange way, because you're manipulating these electrons that can live in many states at the same time through this physics phenomenon called superposition, these internal states of these entities can simultaneously encode, you can imagine, many, many such strings. So many red strings can sit inside one green string. And that's the strangeness of quantum. So simultaneously, you're taking a stack and taking a red string, another red string on top, another, and you build a stack of it. Those all live in a single green string. And now you cleverly take the green string and compute by moving it forward to create another shade of green. That means you move the entire stack of reds simultaneously in some meaningful way, so that the result is what you want. So you can imagine why that's not easy. And the way you do this if you're a programmer is you write this down as some sort of a matrix operation on another matrix. But if you're building a system, it's much, much more challenging. We'll talk about that in a second. So, and this is where it gets really interesting, and that's sort of where it stops getting really interesting. After that, it's basically exploiting what I'm about to tell you. These quantum systems obey something which is, and now confirmed by science, a phenomenon which is somewhat strange called entanglement. So a very crude and inaccurate way of describing this, but it gets the idea across, is if you have two electrons and they're entangled, one is pointing up, one is pointing down. The theory said that if you send one of these two electrons that are entangled to the moon, and then it sits on the moon, and then you change the electron that's pointing up to pointing down, the other electron will change its spin instantaneously. And this is so bizarre that obviously it raises objections. So I'll get to that in a second, but let me walk through why this phenomenon builds on something that's actually very, very significant, and it took a long time. So if you don't get it in day one, that's really no one's fault except that it's hard. So the initial model of the atom, we all know, which my kids in 8th grade study, is called Bohr's atomic model. So Niels Bohr, the famous physicist, proposed this model where there are these electrons sitting in orbits, and there is a nucleus which is protons and electrons. So the time scale you can see for yourself. But the person who really triggered a very, very important break in this and led to what became the modern view of quantum mechanics is Schrödinger. So he postulated, and it's hard to explain this in 1 minute, but I give you the idea. What he postulated was that at the level of an electron, when you take a magnifying glass and zoom into the atom, it is no longer thought of as a particle. It simultaneously lives as a particle and a wave, an electromagnetic wave. And it can have both interpretations. So he wrote this extremely famous, I think it's one of those where he had this leap of intuition, where he could write down the mathematics, because there was not enough scientific evidence at the time to justify it. It's one of those just a flash of insight kind of phenomenon. And just to, I know we all talk a lot in India about prizes. So each one of those I'm tracking were recipients of a Nobel Prize in Physics for that work. So now moving forward with this formalism of a value creation, entanglement was postulated. And then, I'm sure you recognize the gentleman at the left. Everybody knows him. So he took objection to the fact that this phenomenon where mysteriously this equation says you flip something here and something else will flip far away, simply doesn't make physical sense. There's no intuition that justifies it. So he said there must be variables that are hidden that you don't know in the model that are coupling these two things. So he got together with two of his friends, Rolke and Rosen, and they wrote, in fact, a popular paper because of the first author, attacking this theory, saying that he called it, and at the time, if he spoke loudly, people took serious notice, said this is spooky action at a distance. And this is called the hidden variable theory, which in the 60s got debunked actually. But the bottom line, this is not an easy thing to propose, nor is it an easy thing to verify. But lo and behold, many years later, work done from 64 to 1998 led these three people who did really brilliant experiments, because this sort of thing is very hard to define, to receive the Nobel Prize in 2022, 3 years ago. So it's only 3 years ago that entanglement is accepted as a verifiable scientific fact. Through experiment, it was postulated, all sorts of indirect proof was there, but a direct proof is raised. So now, not to intimidate you, but quantum computers take all these things except for Einstein's objection and exploit it through a programming interface. So I can actually manipulate all these things through a quantum computer. And that's the brilliance of the engineering that happened in the last 20 years, which led to machines where you can actually set superpositions up through software, entangle things, and then if you are clever enough to write the right program, let the stack of entangled bits be processed, where when you touch the answer and read it out, you get what you want. So, and we'll see what happened there. So, an algorithm, a quantum algorithm exploits these features. Okay? And this is what everybody is after. Now, somebody in the opening of this session said that in 5 years we'll be looking at a quantum summit like this. It's happening now. There are summits around the world, the equivalent of this, maybe not 1,500 people, I don't know, but they are able to, and a year, our little startup could actually show how you have a problem that can be solved at scale. And therefore, sooner than you think, and that's the name of the company, Quant, we're accelerating the time to which these quantum technologies will use. And it's purely, we live in the software space, all the big giants, they build the hardware. And so, what is happening out there? The next two slides are largely due to McKinsey, the consulting company, and the Boston Consulting Group. They built these projections. So, you have, these are the areas where it's supposed to have impact. It's a long list. I'll get to that a little bit more towards the end of the talk in 10 minutes or so. But the opportunities are many. But how significant are they? So the scale on the y-axis is billions of dollars. So if you look at a modest projection, and this was done 2-3 years before generative AI, the AI piece of that was supposed to grow to $100 billion. And that's the quantum piece. Okay? And now there are all the other normal things like pharmaceutical drug discovery, pharmaceuticals, I'll talk about that, and other areas as well. So if you add it all up, that's close to a $250 billion at that time. But today, or yesterday I heard, I haven't verified, that ChatGPT's market cap, people are talking about to be $1 trillion. Okay? I don't know if it's verified yet, but I heard. Now, if that's $1 trillion, and this was when ChatGPT didn't exist, the quantum AI could be much, much bigger. So these are areas that are just rising extremely quickly. So, is any of this real? Are people taking it seriously? That's a list of companies. Each column is a different type of hardware, technology, physics, who are investing in this area. So you can see, so the names you don't know are startups, but when I say startup, they're spent anywhere from $100 to $250 million building this hardware. And the big ones, of course, right? So we ourselves are partnering already commercially with IBM to validate what we do on their machines, and I'll mention that briefly in a minute, and also talking to other companies. IonQ is a very interesting startup out of Maryland in the US who are doing a different technology than IBM, and Google is invested in this. I didn't list it here, but Amazon also, but they're not as loud about it in the public domain. They're quite much more quiet. That amount of money, and this is old information from 2023, that has already been invested in startups in quantum. So there is over $100 billion invested worldwide in quantum computing startups. The number is a little big because the hardware companies soak up a lot of this. The hardware companies take up 600-700 million of this. And so the leftover for smaller companies like us is in the 10 to $50 million, but we don't need more than that at the moment, right? So, because it takes a lot of effort and people and cost to build these things, right? So, different companies have roadmaps on where this hardware is going. This is IBM's, one of the companies we use actively. So if you see from left to right, basically you just see those names, Falcon, Hummingbird, Eagle, Osprey, Condor, etc. Those are increasingly big quantum machines. And they're rolling them out every year, year and a half. And as they get bigger, you have more of these things, I said, called qubits. So you can use more of them, you can solve bigger problems. That's the whole idea. Okay? Okay. So everybody who's been building hardware, therefore, has a roadmap, and they're all projecting that by 2028, roughly, you'll have a machine big enough to really do whatever you want in a sense, something at large scale. And so that's Google's roadmap. And so this sort of the march goes on. Everybody has a roadmap now. So it's a pretty predictable pattern. So just as this might be just now, qubits do the same thing. After a short while, in the middle of a computation, they kind of fade away and die. So what we just saw was a demonstration of a qubit in real time through the mind. So what happens with these qubits is because these electrons, let's say, are held so delicately in place, a change in an energy infusion to the electron causes it to go to a different state. But that can come from a tiny bump, the famous newspaper article that said a truck driving in New York 50 miles away from IBM facility can send a vibration that can destabilize an electron. So these things are very, very delicate, is the short answer. And that creates a problem. So the fact that when they say I'll have 2,000 qubits in 2028 means that when I'll have 1,000 good qubits that will stay around with us for a while, and hopefully like this might last till the end of the computation, right? So that's the way a typical computation can be thought about. It's evolving in time. Because wire-like fins are entanglements. The grayness means the qubit is fading away. And that's very common. So what we do in the company is instead of investing $200, $300, $800 million to make qubits better, we ask the following question. And that gives you an idea of how to approach this problem.